But how can it be that patent fictions prove essential prerequisites to proper intellectual grasp? And, well, just a few more details of it. So Michael emphasized now merely understanding the mathematical structure of a set of notions does not show how you can live in such a world physically. Okay, I know what the complexified projective plane is, but I don't know how you can live in such a thing. You need a story to take a mathematical structure that you can understand on its own rights and understand how it could be a possible physical world. Okay. Well, that's what the great thought experiments do. They give you enough sense of coordination, or, well, to use the term I think Helmholtz used, it shows you how you could, what it would be like to live in a non-Euclidean world. Now, it didn't do it in the way it's the actual non-Euclidean world we live in, but it was enough to tell you a story so you could see this kind of conceptual possibility as a physical possibility. Okay. And if you don't have a thought experiment like that, without that kind of bridge, well, then it becomes impossible to see these conceptual possibilities as physical possibilities. Now that's a very important contention that Michael's making, and we have to have some sort of approach to conceptual content that does justice to those observations. Okay, anyway, now Michael's resolution of this is that the relativized a priori the positivist is the formalized treatment of those sorts of ties required to pull non-Euclidean skeptics into richer pastures. And he thinks that we can understand the typical character of conceptual advance in science without recognizing the semantic importance of those synthetic a priori prerequisites. And so Michael, this is a quote from one of your books, or someplace you wrote, our current historiography of science requires us to draw a fundamental distinction between constituent principles on the one hand and properly empirical laws formulated against the background of such principles on the other. Okay. Now, anyway, that's the way Michael wants to go, very much in line with, I mean, he's right to say that this was implicit in what Carnap particularly, how they were thinking. Okay. Okay. Well, Quine and his followers, okay, don't have any tools to deal with this sort of question, despite the fact that these are ubiquitous, these sorts of episodes of conceptual enlargement need to be explained and why they have the character that they do. Okay. But when you, under Quine's influence in recent philosophy, has abandoned these diagnostic tools required to operate as effective critics of conceptual complacency. And if you only think about door and doorknob, you don't understand that philosophy is supposed to help us do something real in science, which is enlarge the realm of conceptual possibilities in some sort of plausible sort of way. And we've just abandoned that whole task. And I agree with Michael, we need to return ourselves to a better, to that original scientific philosophy goal. Okay. So we've deluded ourselves that the noble calling of conceptual critic no longer represents philosophies as fair. It's as if we were only willing to study metaethics and had left all normative concerns to those guys. However, it is unfortunately hard to make concrete sense out of the relativized a priori. Okay? And these are common objections that I know lots of philosophers of science that study space-time would worry about. Given the way the issues were presented in Michael's little book, which is very, only actually 3 lectures. But for these kinds of reasons, few of the philosophical remarks that attach to the sundry thought experiments that inspired Einstein's advances are actually implemented within the finalized theory. In particular, it's not unclear, actually hard to make total sense of the idea that any matter follows geodesics within a given relative. Okay. Nor are the philosophical virtues often consigned to philosophical Einstein's events. Clearly displayed within these completed theories, at least so. Now, to me, the generic root of such difficulties traces to the root fact that science rarely advances as a complete and coherent framework in any reasonable sense of the term. At present, there's no happy method for, well, this is actually wedding Maxwell's electromagnetism to any known classical theory of matter. Right? They handle matter and the interaction between the electromagnetic field in a vacuum and its interaction with matter are handled in part in all sorts of ways that can't have any claim to conceptual completeness. So they get, you squeeze your matter onto a boundary condition, you use the macroscopic Maxwell's equation, whose derivation is pretty dodgy and obviously not breaks down, and a whole bunch of other methods. When you actually, is well known, you try to have laws of interaction between matter and the electromagnetic field, you get into the problems Lorentz faced, which is the back action of the field upon the matter. And the only developed theory of that sort is Dirac's, and it really got screwy problems. Okay. So one of the things I was saying to Janan, we should not pretend that we have some, in fact, I'm working on an article, people blithely talk about models of Maxwell's equations, as if it's some complete and self-contained things. We've got to watch where the boundary conditions are. That's only a small part of the universe. It's got to interact. You don't have an interesting optics unless you get some interactions with matter, right? Where does that appear? How is it handled? What are the rationale for handling it in the way we do? We've got to pay a lot more attention to that kind of stuff, and that's where I think the sort of distinctions you get in the theory of differential equations help a heck of a lot to clarifying those sorts of points. Okay. But so the whole thing about having these global or cosmological theories, I mean, they're cosmological models in special relativity, but they only treat the matter as a dust, but it's as a continuously spread out dust, and that is not how you expect matter to be. But that's what those kind of equations demand. Anyway. Well, this kind of says what I just said. Practitioners tiptoe around these alignment problems by treating matter's influence opportunistically by various how do you handle the side conditions to your differential equations. So what Einstein actually contributed to science can only be viewed as a motley collection of equations and inferential techniques that have some truth to them, but do not cohere with one another perfectly, and leave large swatches of physical behavior quite unspecified.